Have you ever gazed up at the night sky and noticed that the stars seem to twinkle, but the moon and other planets shine steadily? It's not magic, it's physics at work, specifically something called as atmospheric refraction. Let's try to break it down. As the light from stars travel through space, it enters Earth's atmosphere, a thick blanket of air made up of many layers with varying temperatures and densities. These layers act like tiny moving lenses. They bend or refract the star's light by slightly different amounts as it passes through. Because of this constant bending or refraction, the path of light keeps changing. Sometimes a little more light reaches our eyes, sometimes a little less. This causes the star's brightness and apparent position to change rapidly. That's what we call as twinkling, or in technical terms, stellar scintillation. Now, why does moon or other planets do not twinkle but they shine? The key difference here is distance and the size. Stars are so far away that to our eyes each one looks like a single point of light. Even a tiny disturbance in atmosphere can make the point shift or dim. But moon and other planets are much closer to Earth and they appear not as points but as large disks. The light from different parts of moon and the planet's surface passes through many parts of atmosphere. There is very little distortion which is caused by air, and that is averaged out. So overall, moon's brightness remains steady and moon does not twinkle. To sum it up, stars twinkle because their light coming from a single distant point gets refracted by turbulent layers of air. The moon doesn't twinkle because its larger, nearby disk averages out the tiny variations in the upper atmosphere. The next time when you look up at the clear night sky, you'll know the twinkling of stars isn't a mystery of magic, but a beautiful dance between light and our ever-moving atmosphere. For more such science explainers, subscribe to UPSC Simplified.